Hello everybody. So today we're going to look at how parametric equations relate to projectile motion problems. Projectile motion is something you've done in the past, but when you did it, you actually only looked at something going straight up in the air. So all those problems you did with negative 16t squared and so on, it all had to do with this, ball being thrown up in the air and coming back down right below from where it came. It involved an initial velocity. So the smaller the initial velocity, the lower it goes, and the higher the initial velocity, the higher the ball goes. The equation that you used was this one right here. You might recognize that from last year. This is the negative 16 has to do with acceleration due to velocity, and the initial velocity there is specifically for the object. We're going to combine this with what we did in our last chapter involving vectors, where x is associated with cosine and y is associated with sine, and that's kind of the way it's always been because the opposite side has always been associated with the y value, and the adjacent side for cosine has always been associated with the x. Okay, so now the new version of this is that balls are no longer only going to be thrown directly up in the air, they're going to be thrown at an angle in a direction. So it's going to go both vertically and horizontally. So if I throw a ball like this, it went horizontally, it also went a little bit vertically too. The larger the angle, the more vertical it's going to go and the less horizontal it's going to go. And the harder the initial velocity, the further it goes in both directions. The equation is a combination of those ones we looked at earlier, where the y component is negative 1/2 g, that's acceleration due to gravity, t squared v sub 0 sine theta is the coefficient in front of t, and h sub 0. So a very similar equation to the one on the other page for the height. Now the distance is v sub 0 cosine theta times t, where this is the coefficient for the x value. So just like in past topics, the cosine theta is with the x formula and the sine theta is with the y formula. What this does is it makes it so that that initial velocity is distributed into both the height and the distance, and the angle at which you're using impacts how much of that velocity is used for each of those components. In the next video, I'm going to take you through an example problem. Hope you understood this.